A classroom has a row of 35 coat hooks. Paulina likes coats to be equally spaced so that there is the same number of empty coats before the first coat, after the last coat, and between every coat and the next one. Suppose there's at least one coat and at least one empty hook. How many different numbers of coats can satisfy Paulina's pattern? This is quite difficult. Let's make an example sequence of coats and hooks. I'm going to call a line an empty hook and a circle a coat. This would be correct. Why? We have the same number of empty hooks after the last one, before the first one, and in between each one. Over here, if you look at another example sequence, this is still correct. Why? We have 2 before, 2 after, and 2 in between every one. I see a pattern here. Let's say we call this a group of empty coats, a group, and another group. We always have, like, let's just call each group, I don't know, E. E is equal to C, which is our coats, plus 1. Why? We have 1, 2, 3 empty coats and 1, 2 filled up coats. Over here, same thing. We have one group here, another group here, and another group here. Again, we have 3 groups and 2 coats. Same thing applies. E is equal to C plus 1. This tells us something. If I write E is equal to C plus 1, that just tells us the amount of groups there are. If I wanted to write an equation for the total amount of coat hooks, firstly, they tell us that there's 35 coat hooks. I'm going to write 35 equals C. I'm going to write C first because C is the amount of coats there are. C plus E. E is the amount of, not E. Let's create a new variable. Let's call this variable D. D, and I can write D is equal to the amount of empty hooks in each group. Let's call that D is equal to D times C plus 1. That is our finished equation. Why? C is the amount of filled up hooks. C is the amount of hooks with a code on it. That makes sense. D is the amount of empty hooks in each group, and C plus 1 is the amount of groups. So if we multiply the amount of empty hooks in each group with the amount of groups, we're going to get the total amount of empty coats. And coats plus empty coats is equal to the total amount of hooks, which is 35. Expanding the brackets, I can get C plus CD plus D is equal to 35. Now, I can use a cool factorizing trick. It's called Simon's trick. It's really, really useful. I'm going to do 35 plus 1 is equal to C plus CD plus D plus 1. You'll see why I'm doing this in a minute. Now, factorizing this, first I'm going to get 36, and 36 is equal to, I'm going to cut this in CapCut 1 minute. So 46 is equal to C. Yeah, okay. So 36 is equal to C plus 1 times D plus 1. Right, and this is perfect because C times D is CD, C times 1 is C, 1 times D is D, and 1 times 1 is 1. Now this is so useful. Why? Because now we've got a really simple equation which we can find the value of C for. Now it tells us there's at least one coat and at least one empty hook, right? So then I know that C must be greater than or equal to 1. And same for D. D must be greater than or equal to 1. Because if there's at least one empty hook, then there must be at least one empty group. Now I can find factor pairs for 36. So basically, which values of C and D satisfy this equation? Okay, so for 36, and none of them can be 1, so I can't have 1 and 36, and I can't have 36 and 1. I can have 2 and 18. I can have 3 and 12. I can have 4 and 9. I can have 6 and 6, but wait, that's not all. I can have 9 and 4. I can have 12 and 3. And I can have 18 and 2. Why? Because if you call this lane C, and if you call this lane C over here, and you call this lane D, then there's a different amount of coats each time. We have 2, 3, 4, 6, 9, 12, 18. Now we can get our answer. We have 1, 2, 3, 4, 5, 6, and 7 different number of codes that can satisfy our pattern. Our answer is D, 7. This was a really difficult question.